Welcome everyone. We are diving into the basic of the Dockers today, a tool that has fundamentally changed how we build and deploy softwares in the DevOps world. If you are using or working in a tech, you are using containers, you will be very soon. This session is designed to give you a solid foundation on what Docker is, why it became an essential part of our modern software delivery pipelines. We will focus on the core concepts and how they apply to your daily work as a DevOps engineer. Let's start by looking at why technology is so critical for us. So why is Docker such a big deal in the DevOps? It all comes down to solve the classic "it works on my machine" problem. Because Dockers, we constantly struggle with dependency conflicts and applications behaving differently across environments. This was a massive time sink. Docker solved this by making application truly portable. It packages everything needed to run the application code, runtime, libraries into one standardized unit. This means the exact same application runs everywhere, from the developer's laptop to the production cloud. Make it standard for CI/CD. Now that we will know why it's matter, let's define what Docker actually is. Docker is essentially a containerization platform. Think of it as a standard way to package your application and all its depend on into a single isolated unit called a Docker. This isolation is a key. It's ensure your application runs constantly regardless of underlying infrastructure. Because Docker containers are lightweight and fast, they execute quickly and efficiently. This open source technology has become the industry standards for packaging running modern applications, but with a specific pain point does this technology address. Before Dockers, our deployment process was often judged by inconsistency. We spent too much time debugging dependencies conflicts, manually setting up environments, which slowed everything down. Docker changed that completely. By using containers, now we have the constant environment across development, testing, and production. This consistency leads to the fast deployments and makes scaling our applications much easier. It removes the friction from the deployment process. Now let's look at the technical differences between the containers and the older technology they often replace, virtual machines. When we talk about the containers, the first comparison is always the virtual machines or VMs. The key difference is resource usage. VMs are heavy because they required a full separate guest operating system for every instance, leading to slow startup times and measured in minutes. Containers are, on the other hand, are incredibly lightweight. They share the host operating systems like kernel, which eliminates the need for full operating system copy. This allows containers to start in a seconds and use far fewer resources. Understanding this architectural difference is crucial for maximizing efficiency and density in your infrastructure. Now that we understand why Dockers are better than virtual machines for many use cases, let's look at how Docker actually works under the hood. Docker isn't a single piece of software, it's a client-server architecture that manages the entire container lifecycle. The core components are the client and the daemons and the registry. The Docker client is simply the command line tool you use every day, like when you type Docker run. The Docker daemon is the engine running in the background that handles all heavy lifting, manages the images and running containers. And the registry, like Docker Hub, is where you store and share those container blueprints. Understanding the architecture helps you to troubleshoot and understand the flow of commands from your terminal to the running containers. Let's start by defining the most important blueprint in the system, the Docker image. The Docker image is the foundational concept we need to grasp. Think of it as a blueprint or the recipe for your application environment. An image is read-only template, contains everything your application needs to run: the code, the runtime, and the tools and libraries. It builds using a simple text file called a Dockerfile, which we will look at the next. Crucially, images are immutable, meaning once you build one, it never changes, which is the key to ensure consistency across the environments. So if the image is the blueprint, what happens when we actually use that blueprint? That give us the container. If the image is a static blueprint, the container is a living, running instance of that blueprint. This is where your application actually executes. A container is essential and isolated process running on your host machine, but it has its own dedicated file system and the network stack, all defined by the images. The isolation is lightweight, which is why containers start up in a milliseconds, not a minutes like a full virtual machine. This speeds and isolation make containers perfect for microservices and rapid deployments. Now that we know what an image is and what is container is, right? Let's see how we actually create that image blueprint in the first place. The Docker file is a simple test file that defines exactly how your image is built step by step. In the source code of your container image, each instruction in the Docker file creates a newly layer in the final image, which is powerful concept for coaching and efficiency. Commands like from specify the base of operating system or a runtime you want to start with, like a specific version of a node or a Python. Run command executes during the build process, typically to install dependencies or compile code. The cmd command instructions define the actual command that runs when the container starts up. Once you have a Docker file, you will know the commands to turn it on running application. These are the core commands you will use every single day when working with the Docker. Mastering these is essential for every DevOps role. The process usually starts with the Docker pull to grab an image from the registry, or a Docker build if you are building from a Docker file. The most important command in a Docker run, which is Docker run. The most important command is a Docker run, which takes an image, turn it into the a running container instance. You use Docker PS for checking which container are currently active, Docker stop command to gracefully shut down them. These simple commands allow us to manage the entire lifecycle of our application from the development to production. Next, we will put these commands together into a simple workflow. Now that we have covered the basic commands, let's look at the simple end-to-end workflow for using Docker in a project. This flow is the foundation for everything we do with the containers. We start by writing a Docker file to define our application environment and the dependencies. Then we build that file into immutable image, which is executable artifact we can test locally. Finally, we push that image to the registry so it can be pulled and run constantly in the production. These 5 steps process is how we achieve the promise of build once, run anywhere. This simple workflow is what we automate when we integrate Docker into our CI/CD pipeline. The real power of the Docker emerges when we integrate it into our CI/CD pipeline. This is where DevOps engineers spends a lot of their time. The process is straightforward. A developer commits code and CI pipeline automatically kicks off a build. The build pipeline uses the Docker file to create a new image, then pushed to secure registry like a Docker Hub or ECR. The key is that the exact same image that pass all the tests is what the production server pull and run. This eliminates environment drift and make deployments incredibly reliable. To use Docker efficiently, we need to follow some best practices that the pros uses every day. If you are building image, always start with a small base image like Alpine to reduce the attack surface and a build time. Remember the containers philosophy, one application per container, which makes scaling and troubleshooting much easier. Also use our Docker ignore file to keep unnecessary files out of your image layer, which speeds up builds and keeps images clean. Finally, never run processes as a root user inside the container. This is a major security risk. We just covered the best practices, but let's quickly look at the flip side. The common mistakes we see beginners make with the Docker. Avoiding these 4 pitfalls will save you a lot of headache and wasted time. First, huge images are a major performance killer. Remember to use multi-stage builds and minimal base images like Alpine to keep your image size down. Second, never hardcode securities in your Docker file. Use environment variables or a proper secret management system like a Vault or a Kubernetes secret. Third, containers are designed to run a single process, so avoid trying to cram multiple applications into one container. Always clean up unused images and containers. They eat up disk space quickly, especially in development environments. Understanding the common errors help us build more robust and efficient containers. Let's wrap up everything we have covered today. We have covered a lot of ground today. So let's discuss the most important concepts in the five key takeaways. The core values of a Docker file that it solves the classic it works on my machine problem by packaging the application and the environment together. Remember that the Docker are lightweight and fast, offering a huge advantage over traditional virtual machines. The Docker file is your automation blueprint, defining exactly how your image is built layer by layer. Crucially, images are immutable templates, while containers are the running instances created those templates. Ultimately, Dockers are essential for modern CI/CD pipelines and any cloud-native deployment strategy. Now that you have a solid foundation in Dockers, let's look at where we go next in the series. In the next video, we will introduce Kubernetes, the industry standard for the container orchestration at scale. We will cover the basic architecture and core concepts you need to start managing complex production grade containerized applications. I look forward to seeing you. Thank you for watching this.